It's a bit weird. Symbol, function name. Well, it's clearly not a function. Function. This is the function. This function name is not a function. It's that, actually. The source file line number is correct. In this case, the source file is a header. And I get the compilation unit, I guess, here. Object file, so the library name. And this is the executable. Another library name, again executable, and again executable. It was good. Source file, good, good. Probably good, good. Not available. The symbol is the function. I'm printing function somewhere and then not a function. So rather here. Very strange. The file name or shared object. Well, that contains the address. Okay, so that is the object file. Damn it. No, still have it. Or not. That used to work last time. Didn't it? Doesn't it? Shouldn't it? What the heck, man? I'm lazy. I'm going to use ChatGPT for everything. Yeah. It already tells me to use that. Resolve. Yay. No, I'm stumped. I just changed this. Oh no, I see here I changed. So it prints that instead of object file. No, but this is another one here. Function and stuff. The DL address is very, very not usable. So this is never set. Isn't that strange? Yeah, I was looking at the wrong chat again. Still too hot to drink. So this is only printed once. Why? Because I did not change it? Huh? What? It's putting it here. So only once DL address is returning non-zero value. And everything else then should be coming from this print stack trace. Yep, indeed. And then it prints function anyway. I'm so not getting this. Where's the call to resolve address? Okay. So I'm having a resolve address, passing the info, which still prints the wrong thing. Okay, let's see if ChatGPT knows this. What is the... no, let's say most common reason. Most common reason that DL address would return 0. Why's the thing become so slow? This is nonsensical. ChatGPT may produce inaccurate or no information. Oh, there it is. Yeah, one word at a time. I think it actually generates one word at a time. Well, that's not the case here, so no. Let's look up the manual then. Well, just let's use Google. Bugs. Usually you have a returned value. Oh yeah, return 0. If a mapped shared object containing address cannot be found, DL address returns 0. In that case, a message detailing failure can be retrieved by calling DL error. we should do that then. Or print it anyway. So really deal open, or what are we talking about? Deal address is only available for objects opened with deal open. I'm now assuming, which would indeed only be the actual shared objects. I'm guessing then not stuff directly linked to the executable or the executable itself and any other object files directly linked to it, such as static libraries or .o files. Moreover, I'm only calling it once. So that is that's why it prints it only once. Let's just keep an eye on a possible error anyway. Yeah, so it's just not failing. It is not failing. I don't like IDs. If deal address now resolve address takes the info. So what is that going to do with it then? It opens get debug symbols path. So that's the path that to the file that contains debug symbols, if it's not the same thing. And then we start using a libdw, which is the DWARF reading thing. This must be past a file descriptor. You're not getting any errors, so it's not printed. So this works. Get the debug information entry. Also no error. Well, this is wrong. It's not a function, it's a die, some die. Which die is this then? That is the die returned by dwarf address die for func address. It's not clear that that is a func address. Gonna change this in dry. Now we have another function here. We already used that. This one here, read build ID. That's also used then by the get debug symbols path function. And then we have the resolve address. Below that we have the print stack trace, which I'm not calling at the moment. And then that's the whole file. What is this thing doing? It's calling libunwind. We're using libunwind to get the whole stack trace. Get function name and offset. It's calling deal address again on addresses, and we do the same thing as before. The same thing as in main, but then for every frame in the stack. Okay, so the stack trace does not involve this line. It clearly goes down the stack. We start somewhere and then we get, well, that's main already. And then we get, well, a previous call and a previous call. Start. So the start is in an object file that is literally linked. This is some .o file. But it still, yeah, and it still returns the file name. It is linked into the executable. While here we get, let me highlight this. Here we get yeah, the file name of the object file, which is then the executable, or the name of a dynamic shared library. And again, and again, and again. I'm used to calling that the object file, so I think we can clearly state that the f name is the object file. This seems also to be working. I'm actually reading the debug symbols of the libc library from some external file. And apparently the first debug information entry is for the same thing, well, the compilation unit. So that would be the same as it is here. The die name, and again. And here we have, well, the compilation unit file name, which is not necessarily the same as the source file, because that could be a header. Same thing here, but now it's the same file. It's not the same file. Interesting. Well, I have no clue why this path is different. A possibility is that this is the compilation unit, so that is the main.c file, and that then includes that one. That would be a possibility, even though it ends on .c. So I think we need 4 things. I'm looking for 4 things, and that is the name of the compilation unit. So that's the die name here. And the object file name, that would be this one. No, more even. And the function name, that is in the symbol. And then the source file and line number. everything I want is here, and it's using something sophisticated to get that. And then looking at the whole stack trace, do we have all of them every time? This one has no sim. We ignore that. Then we have function name, function name, function name, and function name. That works like a charm, except for the first one. And we have, well, this one is special because it's just way too down. I'm having, well, the source file line number in all of them. And then I need two more. The object file name. Yeah, that was also everywhere. Then the only one that I didn't mention was the compilation unit name. So that would be the die name here. So let's give them more recognizable names before I'm completely getting confused here at my old age. The die name here is apparently the you gotta be kidding me, right? Object file. Is that the object file? Oh, that's the F name. The die name, yeah, the compilation unit. And the DLIF name is the object file name. Code duplication. I have to split that off because it's totally code duplication. It's like a stub in front of resolve address. Might as well make it resolve address itself. Yeah, okay, let's do that afterwards. Sim seems to be the function name, but there's one missing here. Source file line number is already in full. The DLS name, there's only one of them. Only here. But that's just a repeat of the symbol name. So, well, and it fails almost all the time. That is probably the better thing to ask then. No, you cannot do anything, then click regenerate. You cannot even ask it. Oh, I can edit this one. That's the correct answer. DL address can only see functions exported in the dynamic symbol table. Most likely NM-D grep shows nothing. Those marked with U work without DL address. They get exported automatically somehow. U is just the undefined, so they are then not exported. They're defined somewhere else. Unresolved here. See that there are a few answers below which tell you to add R dynamic or export dynamic to solve the problem. These answers don't explain why. They aren't an actual answer to the question. Jesus. And don't explain the cost solution. First adding those is preferable because that is the compiler front-end flag. So if I add R dynamic, that would cause all my symbols to be exported, and then we should see more of them. Well, I don't know. I thought until recently at least, Linux export symbols by default. So, as opposed to Windows. But okay, we can investigate if this makes a difference, I guess. So we compile it like this, and then I pass R dynamic. Then maybe more stuff is totally. So this one was seen before. Now we also see this one, and this one, which is simply the now exported symbol for main from object file resolve address, which is the one that I'm just recompiled. Which then obviously did not have any influence on the libc library because I didn't recompile it, and that still doesn't have that exported apparently. Although it does have that exported, not that. That would then still be interesting, I think, to see. Does that have to do with debug symbols? I don't think so. No. Debug symbols is something else, and which symbols are exported. So if I look at nm minus d, what was it? Capital D. All that thing. I look for this symbol name, then we should find it. And if we look for this symbol name, then it should not find it. But it does. Oh. Maybe the double at here is the reason. I don't know. This one has one with a single at. It's a bit fake, I must say. It's about the same info. Size. Well, that shouldn't be anything special. Let's see if ChatGPT realizes something if I tell it this. By the way, yeah, no viewers, hardly any viewers. Who is still there? According to Stack Overflow. I guess there's two ways to look up stuff. Well, either you want to have an answer, and then you want that answer as quick as possible. No, that's not what I'm after at the moment. I'm just learning. So I keep digging and testing things and trying things out, and I'm not really concerned with the time that it takes or the speed. As long as at the end of the day I learned a lot about symbol tables and dynamic stuff and everything. So according to Stack Overflow, blip. Omkar, hello. Yeah, the biggest picture is in the description, and currently I'm just trying to figure out why. Using minus R dynamic, so exporting all this. Well, that's not true. We are talking about this one. Why this symbol is not returned as a DLI S name in the struct that is returned by DL address, while this one is. So they say that you can only get this one if it is exported as a dynamic symbol, but I wouldn't know why not, because I see it here. Okay, so this single add or double add symbols in the output of readelf and nm-d are related to symbol versioning in shared libraries on Linux. They indicate which version of a symbol is being used or provided by the shared library. Here's what I mean. A double add. This indicates the default version of a symbol that will be used when resolving symbols dynamically at runtime. If a program doesn't specify which version of a symbol it needs, it will get the one marked with double add. This indicates an older, non-default version of a symbol that is still available for compatibility. With older programs might request it explicitly. The difference between those two, the default when a program is linked against this library, shared library, and uses the symbol without specifying a version, the version marked with a double add will be used. The non-default version. This version is available but will only be used if a program explicitly requests it. This is useful for maintaining backwards compatibility. Why DL address might not find libc init first. Even though libc init first appears in the dynamic symbol table, DL address might not be able to resolve it for various reasons. One possibility is that the function is not actually called directly by your program. It isn't, I guess. Well, I don't know. Maybe it's inlined. Or any shared libraries it uses, so it might not be loaded into the program's address space in a way that DL address can find it. Another possibility is related to symbol interposition. The GNU-C library often uses internal mechanisms to resolve symbols, which might not be visible to DL address. In summary, the presence of a symbol in a dynamic symbol table doesn't guarantee that DL address will find it, especially not for symbols within libc. It often uses specialized mechanisms for symbol resolution and function invocation. Yeah, I guess if I want to dig deeper into this, I would have to do a test with a self-compiled shell library, which I then include in the stack trace and stuff like that. But I think that goes a bit too far at the moment. So we'll just we'll just declare DLI S name as unusable, because yeah, now I have 4 of the 5, but I even have this one already with my sim. And if I don't use R dynamic, which I shouldn't, where is it? So if I remove this R dynamic, which would be well, normal. then we don't have any S names for the resolve address for the executable itself anyway. In other words, let's get rid of it because it's not adding anything. I'll add a comment. Those is only available for dynamically exported symbols, and even then deal address might still not be able to resolve it. Therefore, DWARF is well, not really useful. Comment it out. Plus, I want to get rid of. Oops, I meant that. I want to get rid of this code duplication. This whole block here is the same as what we have here. So I'm going to include the whole block in the call to the resolve address itself. Yeah, why not? Do not really see a reason why I would not do that. So redefine resolve address. Might as well let it accept. No, I want it to accept a void pointer. And then that should do this whole block. And then the same thing here. Which should do this whole block. What the hell? 2 less than. No, 1 less than. No, I messed something up. I messed something up. I mean, what the hell is this? IP sim blah 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 blah. No output anymore. Bullshit. I'm returning. What the hell? What the hell? Also, that is not printed. Yeah. Okay, why do I not have a function name? This thing here, this, of course it is inside a function. It's inside main. Well, I'm calling resolve address, which is not printing symbols at all. It just doesn't. Okay. Yeah, I'm using the wrong library, basically. I don't want to use the unwind library to get the procedure name, okay, the function name. This uses a cursor, which probably means that it's a pointer into the stack trace. You can go up in the stack here. I want to have a function that I just pass an address and that then prints the function name. So it's nice that this thing returns 0 while it is still while it makes still sense ish, because I don't know, would it end on this? Guess this is the end. Yeah, I don't think this ever fails. So let's do that and then see that that is never printed. I need a function name in here. So we have a sim here, but that's in the stack trace. And I get this well, procedure name really from libunwind, which is, I use libunwind to get stack trace, but what I really want is a function that I can just pass some instruction pointer and then gives me all this data. Now this was the resolve address, but this is then hijacking the libunwind. So what you want is that this same thing appears again here. And before I was assuming, apparently, because it happened exactly once, that this sname thing would print it, but it doesn't. So I'm going to have to get the function name from the DWARF information, I think. As well. And then we would have then we'll get the function name main here as well. And here we get function name main. And then we have it just duplicate, and I can ignore this. And then it's all libdw. Okay, I analyzed this, which I wrote, I don't know, a month ago, 2 months ago. I made another one, and I want to know what is the latest one and what it can do. So we have git status, the resolve. I guess the build ID thing was just to figure out how to get the build ID. Is opens okay, so object file as an elf file, and then it gets section header until it finds a node, and then it looks for a specific node, and then we found a build ID. That's a lot of effort to get a build ID out of the an elf node section, but, or GNU node, whatever it is. But in the end, it doesn't do anything else than print it. Print the build ID. I'm not sure how I did that in the other case here. Get the build ID. Okay, so that would be this function. Read build ID. Okay, well that's the same stuff then. Yep. So that already contains it. This one contains this one. And then we have one more, which is find function. It's just printing the DLIS name, which I just... Well, no, that's not true. Find function name for IP. That's what I want. Yes. Let's see if this works then. Does it say how to compile it? Doesn't. Not nice. Can I still find that in my history? Yep. Let's recompile it. So DL address fails, and then this, I guess, does not fail. Get test address. Is that the function? Yeah, that must be the function, because that's the function that gets the address, and then the address is part of that function. See, this is the one that returns the IP. Now IP points to the return address of the above unwind get context call, aka the unwind init local. This is where it points to, the IP, which is inside that function, indeed. So this works, and then I have to combine this one with the other, and then we have everything in one file. Hey, warlords. Alright, I wanted to put this in at the top before it disappears from my history. And while I'm at it, the other one. VI resolve address. Yep. Go to the top. Compile as. Now we did that. Let's have a look at how this works. Find function name for IP. Get the file descriptor to the elf object. initialize libdw, get address ranges of the compilation units in this object. Get the address range of the compilation unit containing a rel IP. Extract the offset into the .debug info. Obtain the die of the compilation unit. We already had that one in the other file. So it literally prints out. Let's see here. This is the first die that we get, and then you have the name. If we can get it named, that's called the compilation unit. And then we get a child of that. The first child of this die. Well, that could be anything. And then we iterate over all the children of the compilation unit until we find the tag subprogram. That's the function. But declarations are subprograms too, so we test that and just skip them. Check if this is the function that contains a rel IP. DWARF has program counter rel IP, then we found it. Totally cool. Yep. Okay. Yeah, the main problem with this is, of course, that it contains a lot of initialization code. You wouldn't generally not want to do everything every time. So I have to split it up, I think, into a part that can be done only once, and then part that has to be done for every function. At the very least, we can do the library initialization and finding all the A ranges just once. Address ranges are, I think, simply what you get from the proc memory map. So let's say, yeah, then it has to run. Let's see what I will have running. Not much. No, nvim is running. So that one is nvim. Doing ls proc PID, and then we have a maps thing here. /maps. So that this gives for that executable, which is an editor, all the address ranges. For example, this address range corresponds to that object file, and that's basically the information that is returned by the A ranges. And so if then, say, my executable asks for some random address, we just can immediately look up, okay, that's in this address range. So that's an address inside, well, let's pick this one, an address inside that library. And then I think currently I'm also initializing, I mean, that is of course a rather limited number of shared libraries, so you might as well do that whatever you can do for each of those libraries. yeah, I'm not going to open them every time, I think. So I think I want to have a list of all the functions. So you have I make this turn shared object into a C++ object, and then I can just pass that my address and get immediately the function that belongs to that. But yeah, on the other hand, you also want to know the line numbers, right? Source file line numbers. I don't know yet. I think I'll just have to move stuff around a little bit. Let's first put everything in a single file. Can't remember that the other one calls A ranges. Well, I saw it, but I thought it was commented out or something. So let's edit both this one and this one. So I want to move the extra stuff that I wrote for this one into that one. So then in the end, this is just the whole thing. Contains all the code that we need. Well, let's just start at the top, I guess. We have an open for an elf path. That's just, I don't know what that is, but then we call dwarf begin on that. So we definitely should have that. Yep. Aha, so that is dwarf. It is dwarf begin, yeah, of course, called on that external file, possibly an external file that contains all the dwarf info. So we already have that one, and then dwarf A ranges is being called on that. I don't see that. There's something here that's commented out. Get the die debugging information entry for the function. Yeah, I don't think so. That's not a function. It's more like the relative address. No, the function refers to the whole block. So this func address. It's kind of weird, right? So here I'm getting all the A ranges. And then we get the starter length and the offset of that address range. So address range here is the same as, let's say, shared library that we're linked with, or all those things from proc PID map. And only then I get the die of the compilation unit. But here I'm getting it directly somehow. So this is using DWARF address die. And this is using DWARF auth die. Where the auth is, of course, the offset. And the offset is, I guess, yeah, fields, I don't know. Oh, I have no idea. I would say the offset of the start here. The offset of the beginning of the A range, address range, in the, yeah, whatever we have here, the whole image. So it should not contain information about the relative instruction pointer here. Oh, it does. It's probably the offset inside it. Yeah, but I don't get it. Yeah, it's literally saying what it is. The offset into the .debug info section. Maybe the A range is more than just a address range, and it also contains internally the information still about real IP. already getting it, but okay. Yeah, well, that is, like I said, I already got it actually, because the compilation unit that we find here is not a function. It's just the compilation unit is like literally the start of this address range. So the offset is, this is an offset into the .debug info section pointing to the DWARF compilation unit descriptor. So offset contains all the information we need to find the compilation unit, or rather to find the information related to the compilation unit, the DWARF information. So then using that offset, yeah, you just find the compilation unit die. This CU being mine. So when I wrote this, I already understood that this is the compilation unit die, of course, so like it says here. So that's why I wrote it like that. And then in the other file, and then we get the name of that. Okay. In the other file, we probably use a more powerful function that just does that under the hood, because I'm just passing a rel IP here directly to this function, which takes an address, and that then immediately fills in that die. So that would be the compilation die then, compilation unit die. Okay, let's make sure that this is the real IP. That is the actual address minus the base from the deal address call. Base. Well, so rel IP is IP minus that base, and I guess I keep it calling rel IP. Yeah, it's being passed as rel IP. Yeah, it's still rel IP. Now we use rel IP for address ranges. Oh, I didn't tell it yet. Here it is DW, I guess. Yeah, DWARF begin. Just let's call it DW as well, because here I'm having DW. Very suggestive. basically we can. I don't really need those address ranges. Just don't. When you have the compilation die, I can just continue with. Well, calling this, get the child from it. Iterate over all children. Where is the iteration happening? Continue. And this is the next thing. Cause yeah, if you do continue, it goes here. So we get the next child, and this depends on the current child die and rel IP. So all of that can still be done anyway then. Yeah, I don't know. Yeah, I'm not even sure why I'm asking ChatGPT, because it's a bit unreliable. I mean, ask it in a way that it's logical, most likely to have an answer that starts with yes, unless it's really an expert on the subject and just gets an internal short circuit by trying to answer yes. So then I don't want to use this because it's just slow. Because it would repeat all kinds of stuff that I can also cache. And even though now it's still part of this function, in the end I want to take it out and turn it into something that is cached. I do want to start with the the function with code that I can take out to a one-time call configuration stuff. So I want to start with that instead of the call to a dwarf address die. Get the address ranges, then get the address range corresponding to real IP, and then that better exists. Extract other stuff and then call that function. And then we can continue with that must exist as well. And then we get the name, and then it becomes more special. Right now I already have then the compilation unit die. So let's copy that. Then we go to the next function and we paste that here. Accept that here, it's called funcadder. I think I want to rename that to real IP then. 34 more lines, 33 down, print. Old code starts here. Let's call this real IP. Okay, so this is the CU die. We don't want to call this, so it can also not fail. Then we have a bias for something. And then I call, where's the bloody bias used then at all? Is it used at all? It's totally not even used anymore. And this is commented out, but that's now being done above. So I might as well delete all this because we already do it. And this is the dwarf die name, already have that as well. Die name and not null. Printed, found compilation unit is good enough. Else print that. Dwarf not found. Dwarf, well, everything that's commented out can be gone. No. Dwarf get source die. Func address. Yeah, let's ask the DB. If I want to call in order to get the source file and the line number of corresponding to rel IP, does it die? Have to be the CU die from above? Or could it be, say, the function die itself that contains this IP? Great. So yeah, let's first find the function die then. Let's not indent it yet, so I can find it back easier. Plus, I need to know what to do if this fails. So let's just go back to the other previous file. So we're now here. If this fails, then what do we do? Basically nothing. And that one, get a range, if a range, absolutely nothing. So that one, we can just copy this. And then we do dwarf end again, which is already here. And then I'm going to copy the code that gets the function die, which would be, well, everything does skip stuff, found it, yep, all the way till the while. So at this point we have the die of the function. You can do more with the die here. Thank you for the comment, Mr. Pascarlo. That's where we go do that stuff. Yeah. Mm-hmm. No, I think that should do it. Do we have more of like this stuff, like anything but a space, or can I not use this? Apparently that works. Anything but a space. Toy. Well, anyway, I can use space there. So space followed by that, but then something in front of it that is not a space. So anything but a space. At least once. Spaces and then more than one space. 0 or more spaces followed by anything but a space. Followed by anything. Followed by that. I want to change that back to my own style. Resolve address. Find func. Resolve address. DW is not declared. Well, it's called DWARF here, I think. Yeah. It's a bit short, DWARF, right? I mean, DW is definitely too short. Let's use DWARF. Yeah, here's another one. Even DWARF is used a lot, but well. And the result is object file, found compilation unit, found the function name. So big difference now we have a function name. Ta-da. Failed to get source file line number. Rawr. It's not working. Not working. Yeah, so it's just saying what you want to hear, huh? But we know that. Let's try to see if we can find documentation on it. Haha, DWARF and documentation. The very idea. We can only find code for it, no documentation. For Rust. Oh well, let's look at it. Can't be that different. What was I looking at for? Offline source. Oh, this one. Get source die. Dwarf get source die. Dwarf get source die. Nope. Mutual's documentation is not at all this. Maybe there is comments in the source code, just like my code works. Yes, see you die. There's your documentation edit. Who needs documentation when the variable name is called see you die? Okay, look no further. I think I have still the see you die indeed up here somewhere. See you die pointer, see you die. See you die pointer. Let's use the pointer. Probably have to pass pointer. Do I not? Die name looks very much like a pointer here. And it works. Awesome. So now we have a function name for all of them, I hope. Let's put quotes around that. Found die for function. Ding 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 ding. Function name main start call main start main implementation, and the auth in the blah blah blah. What was the expression? We have a compilation unit. Resolve address. So main is in that. Main is in that. Yeah, absolutely. This is in that. Well, why not? As long as it's a string. Probably should put quotes around it as well, even though it's clearly a path. Well, yeah, it's a string, right? This one is again the one that is different, but the rest has it. Yeah, and the object file. Everything works. So now everything is in one file. And I think I'll just remove the other ones. Git status remove. Let's remove the correct one because it's not in Git yet. These can be removed because I have them. And the find function I just copied, basically. Next step is then to, well, separate the code a little bit into an initialization step and something that you really want to call every time for new addresses. Well, I have no idea what redactor even means, so I'm probably not using any redactor. So I'm using libunwind just to get a stack trace. And this is of course to read the DWARF information, and I'm also using elf stuff. Yeah, probably also necessary. I'm thinking, just in case you thought, what is he doing? In the end, I'm only really interested in resolve address, for now at least. Might be interesting to add a stack trace thing to libcwd, but it's not. It doesn't have it yet. It doesn't have it at the moment, so I should probably concentrate on getting just that to work. Now the compilation unit corresponds to object file object file class type, which contains the full path to the object file. Oh, I don't have that. Makes a copy of it. Finds that. Okay, I just need to pass a full path apparently, and then it's things should still work. Hmm? Hmm. It's a relative thing. Why is it a relative thing here? Yeah, it's a relative path. Probably relative to the current directory. Yeah, it seems that it has a full path here, right? I mean, even I'm calling it like that, and then it prints here the full path. Doesn't here, but that also does not include the dot slash. So this is just the name, the file name, the base name. What is it called? The file name, I think. Mm-hmm. That's bullshit. Location. Yeah, so the foo disappeared, so this is the canonical path. Right, okay, I'll type it in here. Linux convert relative path to canonical. To canonical absolute path. Yeah, but then in real path, yeah, and then now in a program. Thank you very much. There's a function real path. It's just a real path here. Limits standard lib. I think the limits is for the no. Dude, it's just one declaration. How can I need two headers? Same bugs then, right? What is it doing? If you pass a null, that works? You don't have to provide a buffer here at all. Path unreadable or does not exist. There's null and set error to indicate the error. Okay. Yeah, that is thread safe, strangely enough. Oh, this is so weird. It's a non-const pointer, so I can write to it, but it is thread safe. It's not allocated because it doesn't tell me to free it. So what is it? A thread local a buffer of 256 bytes, which exists for every thread. I have no idea how they implemented this. It seems like a huge waste of resources as well. Oh, it does that. The return string is a dynamically allocated. The call should deallocate the 3. I looked over that. That makes sense. Great. Well, in that case, I guess this is the one to call. No, I was going to call p-error, but that's not running to the stream then. I can use, in the end I'm going to use libcwd, I guess. So would we just be a fatal call here? No, string error. Standard string error. Error number. Oh, what is this? Nah, that must be the full path, right? I mean, it is coincidentally the full path whenever this exists. But using a relative path here is complete nonsense. Plus, it starts with the dot. So when you get debug./ yeah, so I have to pass a full path anyway to the get debug symbol path. Hmm. Right, now that still works. Now we have a full canonical path. I'm going to eat. So I'll be back later, I think. Let me summarize what I have to do next. So this thing now completely works, right? If anyone's really interested, I'll just push it to Git so you can look at it. Okay. I'll put it on the paste side. I don't want to push it to Git yet. I think it's C++. Where's C++? Yeah. Yeah, it even says how to compile it. Paste. No, and of course that didn't work. Okay, there are people to play with. I'm going to have a dinner and stuff. So I'll see you later.